Hi, my name is Talia, and I'm a high school senior who's super passionate about teaching others chemistry and math. This YouTube channel is a supplemental resource for anyone who might be having difficulty in their chemistry classes. This week, I'm going to be talking about Lewis structures and polyatomic ions. So if you need help with those topics, keep on watching. And without further ado, let's get started. Okay, so before we begin, you're going to want to have your periodic table out for this video. And so before we talk about Lewis structures, we have to talk about electron dot structures. And electron dot structures are basically a representation of the valence electrons of an element. So for instance, if I were to draw the electron dot structure for iodine, I would just write a capital I, and then I would draw 7 electrons around it because iodine has 7 valence electrons. So an electron dot structure just shows one element, but Lewis structures are 2 or more electron dot structures that are connected. And they are connected through bonds. So as we learned in a previous unit, to fulfill their octet rule, atoms bond together. An atom that needs 1 electron might bond with an atom that can give 1 electron, and together they can both satisfy their octet rules. And Lewis structures reflect that. So in each bond, 2 electrons are being shared. So as I said, Lewis structures demonstrate how electrons are shared between atoms, and you show that with a line between the electrons. So when you have one line, a bond order of 1, there's a single bond, which means that there are 2 electrons shared. 2 lines means 4 electrons are shared, 3 lines are 6, and 4 lines are 8. There will sometimes be leftover electrons after the bond, and those are called lone pairs. And lone pairs are in groups of 2. So 1 lone pair will be 2 electrons. So we are going to practice drawing Lewis structures for compounds. I'm going to start with CH4. So I'm going to draw a C in the center and 4 hydrogens around it. And like I said earlier, Lewis structures are just combined electron dot structures. So the same principles apply. I'm going to draw the valence electrons. Hydrogen has 1 and carbon has 4. Carbon needs to have 8 electrons in order to satisfy its octet, and hydrogen only needs to have 2. So I'm going to connect these 2 electrons, these 2, and these 2. And just to make it a little cleaner, I'm just going to draw them as a line. And then we have our completed Lewis structure. Let's try our next one. We have As, arsenic, and 3 fluorines. Okay, so arsenic has 5 valence electrons, and fluorine has 7. And as you do more of these Lewis structures, you'll learn where to place the electrons in your diagrams in order to make it look the cleanest. But I'm not going to do the circles this time. I'm going to bond arsenic to 1 fluorine, to another, and now we can count. Arsenic has 1, 2, 3, 4, 5, 6, 7, 8, and each of the fluorines have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So now all the elements in the compound have fulfilled their octet rule, and we have our Lewis structure. So next we have silicon dioxide. So I'm going to draw silicon in the center and then 2 oxygens on either end. Oxygen has 6 valence electrons and silicon has 4. So I'm going to first start by bonding everything together once. And if you count, we have 1, 2, 3, 4, 5, 6, 7 electrons only for oxygen. So we know that each oxygen still needs 1 more. And this is where a double bond comes in. I'm going to bond this oxygen electron with the 1 electron on silicon and this with another. So now we have oxygen double bonded to silicon, double bonded to another oxygen. And then as you notice, there are 4 leftover electrons on each oxygen. And I'm going to draw those as lone pairs together in groups like that. So our next example, we have hydrogen, carbon, and nitrogen. I'm going to draw the valence electrons. Hydrogen has 1, carbon has 4, nitrogen has 5. Okay, so we're going to first start by bonding each atom together once. So now hydrogen has satisfied its octet rule, or octet rule is an exception. It has 2 electrons. Carbon only has 1, 2, 3, 4, 5, 6. It still needs 2 more. So we're going to bond it again with nitrogen. That will get it 7. And now nitrogen has 1, 2, 3, 4, 5, 6, 7. And then we're going to bond it one more time. So now both carbon and nitrogen have 8 electrons. So I'm going to redraw this. Hydrogen is bonded 1 time to carbon, and carbon is bonded 3 times to nitrogen. So those are examples with basic Lewis structures. So there are some exceptions to elements that require a full valence shell in order to be stable. There are both electron deficient elements and expanded octet instances. And this doesn't necessarily mean that the elements included in these categories can't have 8 valence electrons, but it means that they can be stable with more or less as well. So the first situation we have is boron, which is electron deficient. So let's say we have the compound boron trifluoride. I'm going to draw the valence electrons. Boron has 3, fluorine, each of them have 7. So we can draw the circles here. I'm going to draw circles again. You can just draw lines. As you can see, boron only has a total of 6 electrons, but it is still stable. So we can draw this Lewis structure like this. But we have to remember to put the lone pairs on fluorine. So this is an example of an electron deficient element. Now we have an expanded octet where the valence shell can have more than 8 electrons. So this can be phosphorus and sulfur. Phosphorus can be stable with 10 electrons in the valence shell. I'll show you how that works. So I'm going to draw phosphorus with 5 chlorines. Phosphorus has 5 valence electrons. Each chlorine has 7. So if we bond these together, these together, these together, these and these, phosphorus now has 10, but it is still stable. So we have 1, 2, 3, 4, 5. And don't forget that the chlorines each have to have their 3 lone pairs, which is a total of 6 electrons because each lone pair is 2 electrons. So that shows that phosphorus can be stable with 10 electrons in the valence shell. So our next expanded octet is sulfur, which can be stable with 12 electrons in the valence shell. And I'm going to do that example here. So let's say we had sulfur and 6 fluorines. Sulfur has 6 valence electrons. Each fluorine has 7. Okay, so now each fluorine needs 1 more electron to be stable because fluorine is not an exception. So I'm going to bond the electrons together. And I got a little squish, but you can see sulfur bonded a total of 6 times. That does not mean it has a bond order of 6, but there are 6 bonds. And each fluorine has 3 lone pairs. So expanded octet elements can be stable with 8 electrons in the valence, can be stable with 8 electrons, but they can also be stable with more. So if I had sulfur and 2 fluorines, for instance, sulfur would have 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. And it's still stable. It doesn't need 12 to be stable. Same thing with phosphorus. If I had phosphorus with 3 chlorines, these could each bond once. Phosphorus would have a lone pair, but it would be satisfied and it would have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, so next we're going to talk about polyatomic ions, which are basically groups of atoms that are bonded together and have a collective charge. And we can draw the Lewis structure of a polyatomic ion, just like we can draw the structure of any other compound. And based on the charge of the polyatomic ion, we add an electron for each negative charge. and we take away an electron for each positive charge. So for instance, if a polyatomic ion has a +2 charge, the overall amount of electrons throughout the whole Lewis structure will be 2 less than it normally would be. And we also can calculate the formal charge of each atom in the polyatomic ion. And that is calculated with the formula that formal charge equals the number of the valence electrons of each atom minus the number of unshared electrons minus half of the shared electrons. And you do this calculation separately for each atom in the polyatomic ion in order to figure out the charge of each atom in the polyatomic ion. And collectively, the charges of all the atoms will equal the total charge of the polyatomic ion. Okay, so our first example with polyatomic ion Lewis structures is going to be BrO2-. Bromine can have an expanded octet because it can put extra electrons in the d orbitals, which is something you'll learn more about in AP chemistry, but we're going to do this Lewis structure anyway. So it's going to have a -1 charge, which means there's going to be 1 electron. There's going to be 1 electron to add. So I'm going to draw the Lewis structure. Bromine has 7 valence electrons. Oxygen has 6. And I'm going to go about this how I would normally go about a Lewis structure. First step, make sure every atom is bonded together. So I'm going to bond this bromine to an oxygen and this bromine to an oxygen. So now bromine is at 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. However, each oxygen is only at 7 electrons. So, and we have 1 extra electron. So what we want to do is double bond the bromine to one of the oxygens and add the electron that we have left over to the other oxygen. So you can choose either one. I am going to double bond the bromine to the oxygen on the right, and this electron I'm going to bring over here. So now I'm going to redraw this. So we have 3 lone pairs on this oxygen, 2 on the bromine, and 2 on the other oxygen. And now the next step of drawing a polyatomic ion is putting brackets around it and writing the charge on the top. Now we're going to calculate the formal charge because we're not done drawing it yet. So with the formal charge, these 2 oxygens are going to have different formal charges because they have different numbers of shared and unshared electrons. So I'm going to label one of them A and one of them B. I'm going to write the formal charge over here. Let's first start with bromine. We have 7 valence electrons minus the number of unshared electrons is 4. Minus 1/2 of the shared electrons. So remember, 3 bonds equals 6 electrons shared. So minus 1/2 of 6 equals 0. So bromine has a neutral charge. Okay, so we have to calculate the formal charge differently for each oxygen. So if we first start with the oxygen on the left, I'm calling it oxygen A. We have 6 valence electrons minus 6 unshared electrons minus 1/2 of 2 electrons, which equals a -1 charge. Now oxygen B has 6 total valence electrons minus 4 unshared electrons minus 1/2 of 4 equals 0. Okay, so oxygen A has a -1 charge, so I'm going to write a negative sign on top of it to show that it has a negative charge. And that makes sense because oxygen A gained the electron and electrons are negative. So that is one way to draw the Lewis structure for BrO2-. After we do this next example, we're going to talk about resonance structures, but I'll leave that for later. Okay, so our next example is NH4+. So I'm going to draw nitrogen with 4 hydrogens around it. Nitrogen has 5 valence electrons. Each hydrogen has 1. And because this is a positively charged polyatomic ion, we're going to take away one electron. So we're going to start first by bonding them together. So we have 1, 2, 3, 4. And then we have one extra electron on nitrogen. That is not enough to make its own lone pair. So I'm going to X it out. I'll do that in a different color. And let's redraw the Lewis structure. And I'm going to bracket it and put a plus, and we have no lone pairs, so we don't need to worry about that. Now let's calculate formal charge. I'm going to abbreviate it. For nitrogen, we have 5 total electrons, minus 0 unshared, minus 1/2 of 8, which is a +1 charge. For hydrogen, we have 1 valence electron, minus 0 unshared, minus 1/2 of 2 electrons shared, which is a neutral charge. So I'm going to put a plus sign near the nitrogen because it's a positive charge. And that is how you draw the Lewis structure for this polyatomic ion. Now we're going to talk about resonance structures, which is basically when different atoms of the same element in a polyatomic ion have different bond orders. So here with BrO2 minus, as you can see, one oxygen had a bond order of 2 and one had a bond order of 1. Now in a different resonance structure, those could be flipped. So there are alternate structures for the polyatomic ion that show different arrangements of bonds and electrons. And that is what a resonance structure is. So we're going to draw the other resonance structure for BrO2 minus. So we will start again with BrO and O. We have 7 here. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. I am going to copy what we already have up here and bring it over here. So this is what we already have. Single bond on the left, double bond on the right. Now we're going to switch it. So we have a charge of -1. So we are going to double bond on the left, single bond on the right, which means there's going to be 1 extra electron here because this oxygen only has 7 electrons. It needs that extra one. And then I'm going to redraw it. So we have oxygen double bonded to bromine, single bonded to oxygen over here with 4 valence electrons or 2 lone pairs on the oxygen on the left and 3 lone pairs on the one on the right. So now I'm going to call this one B and this one A, and I'm going to bracket it, put a minus sign, and we're going to calculate formal charge again. So we also have 2 lone pairs for bromine. So for bromine, we have 7 valence electrons, minus 4 unshared, minus 1/2 of 6 shared equals 0. Oxygen A, we have 6 valence electrons, minus 6 unshared, minus 1/2 of 2 shared equals a -1 charge. And oxygen B has 6 valence electrons, minus 4 unshared, minus 1/2 of 4 shared equals 0. So I'm going to put the minus charge on oxygen A, and that is a different resonance structure. So you can see it's a different arrangement of bonds and electrons. Usually if you're asked to draw all the resonance structures, it'll depend on your teacher whether or not you have to calculate the formal charge each time. But I just wanted to do it again so that you could fully understand the idea. So that is the end of this video on Lewis structures and polyatomic ions. So I hope you enjoyed this week's video on Lewis structures and polyatomic ions. Next week, I'm going to be talking about bonding and polarity, so covalent, ionic, polar, nonpolar bonds. And if you need help with that, feel free to watch next week's video. I'm going to leave a link in the description box to my website with all my information about my YouTube channel and my tutoring if you would like to schedule a session with me to work one-on-one. Again, I hope you enjoyed this video and good luck with learning the rest of your chemistry.